Have you ever wondered what keeps our world moving? Cars zoom down highways, their engines roaring with power. Every day, millions of vehicles traverse the roads, connecting people and places, making our lives more convenient and interconnected. But have you ever stopped to think about what fuels these machines? Airplanes soar across the sky, covering vast distances in mere hours. These marvels of engineering defy gravity, allowing us to travel across continents and oceans with ease. The aviation industry has revolutionized the way we experience the world, but what gives these colossal machines the power to lift off and stay airborne? What is the secret behind these incredible machines? The answer lies in the engines, the heart of these vehicles. Engines convert energy into motion. But where does this energy come from? The answer is a remarkable substance that has shaped our modern world in countless ways. The answer, my friends, lies in a remarkable substance: petroleum. This thick black liquid, often referred to as crude oil, is a fossil fuel that has been a cornerstone of industrial development and technological advancement. But what exactly is petroleum, and how did it come to be such a vital resource? Petroleum, often called crude oil, is a fossil fuel found deep beneath the Earth's surface. Extracting it requires sophisticated technology and immense effort. Drilling rigs and deep-sea platforms are just some of the methods used to tap into these underground reservoirs. But the journey of petroleum doesn't end there. It's a thick, black liquid that formed over millions of years from the remains of ancient marine organisms. These organisms, once thriving in prehistoric seas, were buried under layers of sediment. Over time, heat and pressure transformed their remains into the hydrocarbons we now extract as crude oil. Today, petroleum is one of the most important energy sources on our planet. It powers not just our vehicles, but also industries, homes, and countless other aspects of daily life. The global economy is heavily reliant on this resource, making it a critical component of modern civilization. But how does this black gold actually power our vehicles? The journey from crude oil to fuel is a complex process involving multiple stages of refinement and transformation. At gas stations, we see the final product being pumped into our cars, but there's much more to the story. How does it transform from a sticky liquid into the force that propels us forward? The refining process involves separating the various components of crude oil, each with its own unique properties and uses. Through distillation and chemical reactions, crude oil is converted into gasoline, diesel, jet fuel, and other valuable products. Let's embark on a journey to uncover the science behind this incredible energy source. From the depths of the earth to the engines of our vehicles, petroleum's journey is a testament to human ingenuity and the power of nature. Join us as we explore the fascinating world of black gold and its impact on our lives. Imagine a time long ago, millions of years before dinosaurs roamed the earth. Our planet was a vastly different place, a world unrecognizable to us today. Our planet looked very different then. The continents were not in the positions we know now, and the climate was much warmer. Vast oceans teemed with tiny creatures like algae and plankton. These microscopic organisms were the foundation of the marine food web, thriving in the sunlit waters. When these organisms died, they sank to the ocean floor. Over time, their remains accumulated, forming thick layers of organic material. Over time, layers of sediment, like sand and mud, buried these remains. These sediments were carried by rivers and streams, eventually settling in the ocean basins. The weight of these layers created immense pressure and heat. This process, known as diagenesis, gradually transformed the soft sediments into solid rock. This intense environment over millions of years transformed the organic matter into the substance we know as petroleum. The transformation involved complex chemical reactions, breaking down the organic molecules into hydrocarbons. The energy we use today in our cars and airplanes originates from the sun that nourished those ancient life forms. This ancient sunlight, captured by tiny organisms, has been stored for millions of years, waiting to be unleashed as the fuel that powers our modern world. Petroleum, in its raw form, is not very useful. It's a thick, complex mixture of hydrocarbons, molecules made up of hydrogen and carbon atoms. This raw crude oil is extracted from deep beneath the Earth's surface, often from offshore rigs or vast oil fields. The journey from this raw state to the fuels we use daily is a fascinating and intricate process. These hydrocarbons vary in size and structure, which is why crude oil needs to be refined. The refining process is essential to transform this unrefined mixture into valuable products. Each hydrocarbon chain has unique properties and uses, making the separation process both challenging and crucial. To unleash its energy potential, we need to refine it. Refineries are complex industrial plants equipped with various units and processes designed to handle the different components of crude oil. Skilled workers and advanced technology work together to ensure the efficiency and safety of the refining process. Oil refineries are like giant kitchens where crude oil is separated into different components, like gasoline, diesel, and jet fuel. Each of these products has specific applications, from powering vehicles to heating homes and fueling airplanes. The separation process is meticulously controlled to ensure the quality and purity of the final products. They achieve this through a process called fractional distillation. This method takes advantage of the different boiling points of the various hydrocarbons present in crude oil. By heating the crude oil, the different components can be separated based on their boiling points. Imagine a giant tower where crude oil is heated. This tower, known as a distillation column, is the heart of the refinery. As the crude oil heats up, it begins to vaporize, and the vapors rise through the column. As the oil vaporizes, different components rise to different levels based on their boiling points, allowing for separation. Lighter hydrocarbons like gasoline rise to the top, while heavier ones like diesel settle lower down. This separation is crucial for producing the various fuels and products we rely on. This refining process is crucial for creating the fuels that power our vehicles. Without it, we wouldn't have the gasoline for our cars, the diesel for trucks, or the jet fuel for airplanes. The refining process not only provides energy but also supports countless industries and everyday activities, making it an indispensable part of modern life. Now that we've refined our petroleum into usable fuel, let's see how it actually makes our cars and airplanes move. The heart of this process lies in the engine, a marvel of engineering. Imagine a cylinder inside the engine. Within this cylinder, a piston moves up and down. Fuel is mixed with air and injected into this cylinder. A spark ignites the mixture, causing a controlled explosion that pushes the piston downward. This downward motion is the fundamental force that drives our vehicles. Section 5: Combustion, the heart of the engine. The key to understanding how petroleum powers our vehicles is combustion. Combustion is a chemical reaction, a kind of controlled burning. When the fuel-air mixture inside the engine cylinder is ignited by the spark plug, a rapid chain reaction occurs. The hydrocarbons in the fuel react with oxygen in the air, releasing a tremendous amount of energy in the form of heat and light. This sudden release of energy causes the gases inside the cylinder to expand rapidly, pushing the piston down with great force. Section 6: Power to the wheels or wings. The downward force on the piston, generated by combustion, is then transformed into rotary motion. This rotation is what ultimately powers the wheels of our cars or the propellers of airplanes. It's a fascinating chain reaction. In a car, the up and down motion of the pistons turns a crankshaft, which then transmits power to the transmission and eventually to the wheels. In an airplane, the engine's power spins a propeller, generating thrust that propels the aircraft forward. Section 7: The environmental cost of burning petroleum. While petroleum has revolutionized transportation, it's crucial to acknowledge its downsides. Burning fossil fuels releases greenhouse gases like carbon dioxide into the atmosphere. These gases trap heat and contribute to climate change. Finding cleaner and more sustainable ways to power our vehicles is one of the greatest challenges of our time. We must explore alternative energy sources like solar, wind, and hydrogen to protect our planet for future generations. Section 8: Looking ahead, the future of transportation. The future of transportation is filled with exciting possibilities. Electric cars are becoming increasingly popular, offering a cleaner alternative to gasoline-powered vehicles. Scientists and engineers are also exploring hydrogen fuel cells and other innovative technologies. Imagine a world where cars purify the air as they drive, or planes soar through the sky without emitting harmful pollutants. By embracing innovation and sustainable practices, we can create a brighter future for transportation. Section 9: Share, subscribe, and stay curious. Thank you for joining me on this journey into the world of petroleum and how it powers our vehicles. I hope you found it as fascinating as I do. If you enjoyed this exploration, be sure to share it with your friends, and subscribe to our channel for more exciting adventures in science and technology. And remember, the universe is full of wonders waiting to be discovered. So keep asking questions, keep exploring, and never lose your sense of wonder. Meow!